Welcome to 10 minutes CS. 1106 Parsing a boolean expression. We are given a boolean expression which evaluates to either true or false. That means the answer or the output for this expression will be true or false. And it will be following the following rules. T denotes true, F denotes false, and uh, we can have a logical not, a logical and a logical or for evaluation of that expression. We need to evaluate the given expression, which will be a string, to a boolean expression and find the resultant for it. It is guaranteed that the given expression is valid and follows the following rule. So what does this mean? That let's say we won't have anything like this because we cannot use a not operator for binary or uh, n number of values. It can only be applied to one of them. Also, that and for and we will always have number of sub expressions greater than or equal to 1. So let's say we have something like f, or we will have something like t or f. So it will always be a valid expression. Now let's look at the examples to see how this works. Let's see this one. So we have an expression as this. So first of all we have f, which is false. We apply a or to it. So or of false will be false in itself, and we apply and over it. So and of false will be false in itself. So we will just return false. Let's look at this one. We are given an expression as this. So the and of false and true will be false, and we can apply not operator over it, so it will evaluate to true. So we are returning true here. Isn't this same as prefix polish notation? We are given an operator and later on we are given the values on which that operator needs to be performed. So for this sort of problem, we can have an operator at first and then we will have the values, and we need to perform the action over those values using that operator. That means we will be seeing the operator first and then the values. So what can we use in this case? If we either keep a record of what operator we had earlier and then we are getting the value, so we need to apply the operations over it. So let's take up this example itself. We get the values. Now we need to check what operator was there earlier. Now we evaluate the expression, then we'll trace back again and check what operator was before it and then apply the operation over it. So instead of moving our pointer back and forth, why not we use a stack? Because once we have evaluated, we can just pop it out and can operate over the previous operand, and then later again we can pop it out and operate over the previous operand. Similarly, we can keep on doing that. So one thing is confirmed, that we need to use the data structure as stack. Now let's do some observations for the binary operands. So let's say we have true, 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 false, false, true, and false, false. For an and, only when we have both true, this will evaluate to true, rest all will be false. For or operator, if any of them is true, then it will evaluate to true, else it will be false. So the only condition when and is true is both are true, and the only condition when or is false when both are false. And what about the not operator? For this, if we had false, it will become true, and if we have true, it will become false. So basically the opposite of it. So while doing the stack operation, we see that if we will have a false or true, we can add it to our stack, right? And let's say if we have commas or opening bracket, then we can just continue, because we can't evaluate the expression at this point. And if we have any operator, that means if we have a not or a ampersand or a pipe symbol, that is and or, in that case we can also push it, because later on, later on for applying the operation, we can peek to the stack and see what operation needs to be performed, and using that we can do that. These will be our values and these will be our operands. Now if we will get a closing bracket, that means we need to perform our operations here and need to do the expression evaluation. So here we will check if we has a false or has a true. So we can pop from the stack unless we have got a operator, that means is operator for stack.peek is false. We can pop and check if we has a false or a true. So this will be the case for such that we might have something as this. Among these we can check if we have any of them is false or any of them is true. So we can do it like this, and we keep on popping, and we can check if it is true, then our has true is set to true. If it is false, then our has false is set to false, so that later on when we are applying the operations, we can check whether both are false or both are true, or what needs to be done with the operands. Now once we have done this, we will check what operand we have. So we will do a pop again, and we will see if our operand is and. Now for and, we saw here that the only case when it will be true when all the values are true. So for this, if it has false, then the value will be set to false if any of them has false. Else it will be true, that means that all the values will be true. So, and similarly for or, we can check if any of them is true, that means it can be set to true. So if it has true, it will be set to true, else it can be set to false. Now what about the not? We can check if it has true, then it will be set to false, or else, that means if it has false, that will be set to true. Now we will keep on doing these all these unless we reach the end of the string. So we will have a I pointer which will be starting from 0 till n, and we will keep on doing it. And lastly, at the end of our stack, we will have our evaluated stack output. Let's try to do it over one of the example. Let's take up this example itself. So the example is, we have not, then we have and we have false and true, and we will be having our stack which will be initially empty. Now we started our ith pointer from here. We are at 0th index, 2 3 4 5 6 7 and 8. So we are at 0th index. We saw that it's an operator, so we will push it to the stack. Now we move to the first. Now this is a opening bracket, so we need not to do anything. Now we come to the second index. We see it's an and operator, so we add it to the stack. Now we will move our pointer to next. This is the opening bracket, that means we need not to do anything, and we will just continue. Now we see it's a false, so we will push. again. Now we move to the next one. It's a comma, so we will do nothing. Now we move to the 6th index. This is true. We will push it to the stack. And now we got a closing bracket. Now for closing bracket, we will check while we don't have operand. So we will pop from the values. Now we will have two booleans, has false and has true. Now we pop it over it and we pop this one. This is true. We see it's true. So this is set to true. And we then go to the next one. We pop it again. Now it's false. So this is set to false. Now once that is done and we have received, when we peek, we saw an operand. Now for AND, we will see if any of it is false. That means it will evaluate to false, right? So we saw that has false is set to true. That means one of them was false. So this will be evaluated to false. Now we will push this again to our stack. Now we move to the next index. Now it is again closing bracket. Then that means we need to evaluate the expression. Now all these are removed and this is also removed. We will pop it also. Now we check again for has false and has true. So has false is set to true and this is initialized to false. Both of them will be initialized to false first. Now we check for the operand. This is a not operand. So we check has false is set to true. That means it will become false. So we have popped it, both of them, and we will add this again to our stack. Now finally we reach end of our string. So we can just return if stack.pop is false, then we can return false. If it is true, then we should return true. Now let's look at the code. We have a function is operator to check if it is any of these operator. If yes, then we will return true, else we will return false. We will have our n as the length of the expression. We will initialize our stack, which will be an empty stack at first, and we will keep on checking for each of these indices. We check what is the character there. If it is true, false or an operator, we can push it to our stack. If it is opening or a comma, we can just simply continue. Else, that means we have reached a closing bracket. We will initialize two booleans, which is has true and has false. We will set them to true or false while checking for the values in our stack. So we will check for values in our stack using st.pop. Unless we haven't received any operator, that means we are just getting values such as comma, comma, something like this. We will evaluate among all these. If any of them is false, we will set has false to true. Similarly, we will set true to has true to true. Now once that is done, we will check if a stack is not empty. So if it was simply like this, so we don't have an operator in front of it, right? So in that case, we can just simply come out of the loop. But for an expression like this, we need to check if the stack is not empty. We can get the operator and we will set the new value as empty or just a empty character, and we can check if the operator is not operator. Then in that case, if it is true, it will evaluate to false. If it is false, then it will be evaluated to true. Now for the AND operator, if any of them has false, it will be evaluated to false, else it will be true. And for the OR operator, we will check if it has true, any of them, then it is set to true, else it will be set to false. And we will push the new value to our stack. Now once all of this is done, we will check what is there in the stack. If it is false, If it is an F character, that means it's a false and we will return that, else we will return true. So what will be the time and space complexity for it? Here we are just here we are running over the length of our expression, that is O of n, and here we just push, and after coming here we are checking for the operator and we are popping. That means whatever we have filled in the stack we are popping, that will again be in O of n, and this here we are just running it once, that will be O of 1. So overall it will be O of n square in worst case, and O of n will be the space complexity as we are using stack, and in worst case we have to fill all the expression into our stack. Thank you for watching.